Good evening, sir.
Good evening, everyone. Good evening, everyone.
Good evening, sir.
Just in 1 minute, we are starting with. We'll continue with electricity chapter, which we had started. So just be attentive during the class. Pay attention to the things that we discuss. Also, try to answer the questions on your own, whatever questions are asked during the classes. Okay. I've told you a number of times to keep your cameras on. Still, if you are not doing that, so just I'll say that be attentive. That I think you can. Okay. Everyone, let's see. Right. So in the last class, we had done about electric current. We had seen that what are electric currents. Okay, Moksha, no issues. Keep us updated. Good evening, Aryan.
Good evening, sir.
Okay,
Good evening, sir.
Aryan here. We have Aryan Yadav and another Aryan, right? So see, now you turned on the camera. I came to know that yes, there is another Aryan, Aryan Yadav. Yeah, Aryan Yadav, how are you?
Sir, I am Aryan, sir.
Okay, so Arav, not Aryan. You are Arav Yadav.
Yes.
Okay, okay. Okay, fine. So see, let's continue in the chapter electricity. In the last class, we had done the electric current, and now today we'll try to draw a simple circuit consisting of a bulb, battery, ammeter, voltmeter. That means the basic things which are there in a circuit that should be present in that circuit. So here we can let us draw an electric circuit consisting of a battery of two cells. I would like everyone to draw. All of you draw an electric circuit consisting of a battery of two cells, a bulb, an ammeter, and a voltmeter to measure the potential drop across the bulb. And a switch. So I also want a switch in the circuit to operate all these things. Okay. So let's try to draw the different components of the circuit. So we start with the bulb. There are two ways to represent the bulb. Either you represent your bulb simply like this. So this is your bulb. And you can represent your bulb. Then this bulb has to be connected. We have to connect this bulb to a battery of two cells. So here I make a battery of two cells. I would like to see everyone's answer. All of you also keep drawing. So you should have here a battery of two cells. then it should consist of a switch. So here we should have a switch. It should have an ammeter also, and also a voltmeter in the circuit. So at this place, we make a switch or a key. So switch or a key looks something like this. Then you add an ammeter over here. Ammeter is always connected in series to the circuit. So we connect the ammeter like this. The positive terminal of the ammeter is connected to the positive terminal of the battery, and the negative terminal of the battery, ammeter is connected to negative terminal of the battery, like this. For the bulb, there is no positive and negative terminal, so we have not included any positive and negative over here. The next device we need to add is a voltmeter. So since the voltmeter is always connected in parallel to the circuit, and my voltmeter should measure the potential difference across the bulb, so I will draw my voltmeter something like this. Across the bulb, I will put up my voltmeter.
So, sir, the current will still go through the bulb and voltmeter or only voltmeter? Like, how is it going?
Okay. See, the voltmeter will be connected in parallel to the circuit, parallel to the equipment. Also, the positive of the voltmeter is being connected to the positive side of the battery, and negative of terminal of the voltmeter is connected to the negative side of the battery. Okay. Now I can make the switch on using this. So now the switch is on. But also I can draw the direction of current here. So I can make arrows from positive towards the negative, representing
Sir?
the direction of current. Yes.
So the current will flow through the bulb and the voltmeter at the same time.
Yes. At the same time, at this junction, at the junction between the battery and the between the bulb and the voltmeter, this is the junction of the voltmeter and the bulb. At this junction, whatever current is coming at this point, so this current would try to divide into two parts. But as we know that voltmeter has an infinite resistance. All right. What is the resistance of an ideal voltmeter? Yes, Abhinav, what is the resistance of an ideal voltmeter? Aryan,
Yes, sir.
what is the resistance of an ideal voltmeter?
Mm,
See, this we had discussed in the last class. The resistance of an ideal voltmeter, the resistance of an ideal ammeter. Okay, Arav, can you tell?
Sorry, sir, I didn't remember.
Okay, is there anyone who can tell? Anyone?
Sir, infinite resistance.
Sir, voltmeter
Infi-
infinite.
Yeah, voltmeter has infinite resistance, right? So this voltmeter has infinite resistance. You can assume that this voltmeter here an infinite resistance has been connected in this wire. Infinite resistance means if the current want to enter this part of the junction. So from this junction, the current will try to divide in two parts. Some part of it will try to flow through the voltmeter, and some part of it will try to flow through the bulb. But since the voltmeter has infinite resistance, so a negligible, or however, the real voltmeters do not have infinite resistance. Okay, the resistances are very high, but not infinite. So you can say through the voltmeter, very small amount of current flows through the voltmeter, a negligible current flow through the voltmeter, which is just sufficient to run the voltmeter. Otherwise, no extra current flow through the voltmeter. So for all practical purposes, we assume that whatever current is coming, that current passes through the bulb. That current is not passing through the voltmeter. For all the practical purposes, we consider the same thing. Got it?
Yes, sir.
Sir,
Yes, sir.
Sir,
Okay,
does
what
the
do you
voltmeter always have to be parallel to the bulb?
between voltmeter will be connected between 2 points over where you want to measure the potential difference. It can be something like this also. Suppose if you have two devices which are represented by the two resistances. Let's say this is your resistance R1 and resistance R2. So when I say resistance R1 and R2, so the resistance R1 and R2 can be any resistances. It can be a bulb, it can be fan, it can be AC, anything it can be. Okay. Now suppose I want to measure the potential difference across R1. So I will attach a voltmeter across R1 like this. Suppose I want to measure a potential difference across R2. So I will attach a voltmeter like this across R2. Suppose I want to measure the potential difference between both R1 and R2. So now I can directly attach a voltmeter like this. A voltmeter V3 that will be connected across R1 and R2. Okay. So between whatever points you want to measure the potential difference, you will connect the voltmeter across those 2 points. Suppose here in this circuit, I connect the voltmeter like this. I connect my voltmeter over here. So what should the voltmeter show me? Yes, what will the voltmeter show? Yes,
Sir,
everyone.
Sir, can you repeat the question?
See, in the first circuit, I have connected the voltmeter across the battery. Now, what potential will be measured by this voltmeter? Can I say that it will measure the potential difference across the battery only? Across the ends of the battery or the terminals of the battery? Yes. So this voltmeter will show me how much voltage is supplied by the battery. This voltmeter will show me how much is the potential drop when the current passes through this and some work is done. So this voltmeter is actually showing you how much of the work is done when the charges are crossing this bulb. And this voltmeter is actually showing you that how much capacity the battery has. Got it? As over here, everywhere we define V equals to W over Q. Right? So here we can imagine that if I measure the potential difference between these 2 points, so it means that yes, how much work is done in moving the charges between these 2 points per unit charge. Okay. So if suppose potential difference is 2 volt, that means 2 joule of work is done in moving a charge of 1 coulomb between these 2 points. Understood, everyone?
Yes,
Everyone
sir.
can draw a simple circuit now?
Drawn.
Okay. So see, again, just a quick revision of the different symbols that we had learned. We had learned a simple wire. This is a simple wire. Then we had seen a bulb. We had seen resistance, a bulb glowing, a glowing bulb. Okay. We can have a switch. This is an open switch.
Sir, could you show the previous one, sir?
Yeah, just 1 minute. This one is a closed switch. Closed switch. Okay. Yeah.
Completed, sir.
Open switch, closed switch, a cell, a battery, cell. This is battery. Then variable resistance or rheostat. This is a rheostat or variable resistance. I'll tell you some examples of rheostat or variable resistance. Any other symbol that you can think of? The wires, of course, yeah, the first one is the wire itself. Okay, the others we have discussed, ammeter,
Sir, wire join.
yeah, ammeter, voltmeter, you have fuse. So this is fuse. Wire joint you can show like this.
Sir,
Wire
and wire
joint.
crossing.
Okay, wire crossing without touching. So this is wire crossing without touching. Anything else? Okay, I think these are all the symbols that we'll be taking help of while drawing an circuit, or while representing a circuit, we'll take help of these figures. Okay. Now, we'll be discussing about a relationship between electric current and electric potential. Now, this is very important. And from here, actually, you can see that from here, we are now entering into the core part of the chapter of electricity. Okay. And this part we call as the Ohm's law. So, the Ohm's law, it defines a relationship between current and potential. And it has a wide applications. So Ohm's law, see what does the Ohm's law state? It states that the current flowing through a wire is directly proportional to the electric potential difference between 2 points. Or electric potential difference across the ends of the wire, let's say. When we are talking of the wire, define in terms of the wire. Across the ends of the wire. So now we'll try to understand what does it state. The Ohm's law, it was given by George Simon Ohm. Okay. So according to the George Simon Ohm, if you have a wire and suppose some current is flowing through it. Okay. So the current will only be able to flow if there is some potential difference across the ends of the wire. Suppose this is at a positive potential B, this is at a negative potential. So the current will start moving from positive terminal to the negative terminal. Remember, everywhere we are considering the conventional direction of current. So as per this conventional direction of current, the charges, they move from positive terminal to the negative terminal. So the current is moving from positive terminal. Hey. The current is moving from positive terminal to the negative terminal. Now, this current which is flowing through this wire, it must be proportional to the potential difference. That means the voltage across the ends of the wire. Okay. What is the difference of the battery voltage? Which will be directly proportional to the current. So I can write it that current I it is directly proportional to the potential difference. Got it? The current flowing through the wire is directly proportional to the potential difference. We can also write it I proportional to V, or we can also write V proportional to I. So when two quantities are directly proportional to each other, it means if you try to plot a graph between the two quantities. Suppose I try to plot a graph between V and I. Okay. So the two quantities, they are directly proportional to each other. So here if I represent, I have the two axes. So on any one axis, let us say I choose this one as the x-axis, y-axis. And suppose on the y-axis, I am representing current. And on the x-axis, I am representing the potential. So since the current is directly proportional to the potential, I must get a straight line. So I will obtain a straight line, and the straight line must pass through origin. It must pass through origin, then only we can say that yes, it is directly proportional. So here I have given these two graphs, and yes, these two graphs, they represent that current and potential, they are directly proportional to each other. Got it? So I hope you have understood the meaning of the directly proportional.
Yes, sir.
For example, if
Yes,
we
sir.
talk of speed, distance, and time, so can I say that the distance will be directly proportional to time? The greater the distance, greater will be the time taken. Yes. So when I say the two quantities, they are directly proportional to each other. If you plot their graph, so the graph, first of all, the graph will be a straight line, and the graph must pass through origin. So here, these two graphs, they are passing through origin, and they are straight lines. So they represent that I and V, or V and I, they are directly proportional to each other. Got it? Anyone having any other doubt? Anyone who has not understood what we are talking of? Directly proportional simply means if one of the quantity increases, so the other quantity also increases. When it happens, we call it to be directly proportional. So here, it means that if you increase the potential, hey, so from this, we get that current and potential, they are directly proportional to each other. If you increase the potential, there will be more current. Okay. If you decrease the potential, the amount of current will decrease. This is what is meant by directly proportional. And plotting a graph between them gives a straight line. I will add a few more points in this Ohm's law. But first, let us see. We'll try to verify. We'll try to just take this equation where we have current being directly proportional to potential. So we have current that is proportional to electric potential. Now, if I remove the proportionality, so I can write D equals to I multiply by a constant, and that constant of proportionality is R. So here R is constant of proportionality. R is the constant of proportionality. It is called resistance. So definitely all the wires, they will have some resistance, and the resistance of the wire will be said to be a constant. Okay. So the resistance of wire, it remains constant. When you have chosen a wire, when you have applied the voltage, So the amount of current will only depend on potential. There is no other factor which is determining the current in the circuit. So R is resistance and it is measured in ohm. The SI unit of resistance is ohm, written like this. Okay. So I think everyone will be able to remember this,
Yes, sir.
that V is equal to IR. Yes, can everyone remember this formula?
Yes.
Yes. So this statement is specifically called the statement of the Ohm's law. A few more points I am adding with this definition of the Ohm's law. See, with the Ohm's law, there are certain conditions when the Ohm's law will hold. So V directly proportional to I. The conditions which state over here are you have provided the physical conditions like temperature and dimensions of wire are constant. So if during this process there is no change of temperature, also the dimensions of the wire do not change. Dimensions of the wire means its length, area of cross section, diameter, they do not change. So then we'll follow the Ohm's law. Then Ohm's law will be followed and the current will be directly proportional to potential. Got it? Okay, Kashvi, I'll be explaining a little bit about variable resistance. Just wait. First, let us try to understand resistance. Okay. So, with the Ohm's law, I think everyone is clear that if you plot a graph between I and V, you will get a straight line. Okay. So, these are the two straight lines which are passing through origin. It means that these represent the Ohm's law. Okay. And according to the Ohm's law, the current flowing through a circuit is directly proportional to the electric potential difference across the ends of the wire. So we have I directly proportional to V. And if you remove the constant of proportionality, you get V equals to IR, where R is introduced as the constant of proportionality that we also call as the resistance of the device. Anyone having any other doubt? Okay. So with this, let us first we will solve a few questions and then we'll move ahead. So see, when a bulb is connected to a battery of potential difference, let's remove the battery. Two 20 volts. Find the current flowing through it if it has a potential of, if it has, or if resistance of 440 ohm. Okay. So try to do this question.
Sir, can you
Everything
guys
is,
show the before page?
which one?
Before page. Yes, sir.
So all of you try to do this question. As per the question, you have a bulb is connected to a potential difference of 220 volt. You have to find the current flowing through it if it has a resistance of 440 volt. Kalki? Kalki.
Sir, 1 by 220.
1 by 220. Okay, let us see. We had just seen the formula for the Ohm's law. Yeah, Kashvi, you are correct. So the formula is V equals to IR. And we know the potential is given as 220. So we just put here 220 equals I, that is current, multiplied with resistance, that is 440. So we know now current will be given as 220 over 440. This is also given as V by R. So from the expression you can obtain V by R is equals to I. So V is 220, R is 440. Divide this, you get current. And this is equal to 1 by 2. 1 by 2 means 0.5 ampere. Got it? So what is the current flowing through the bulb? Yes, what is the current flowing through the bulb?
0.5.
0.5
0.5
ampere.
ampere.
The current flowing through the bulb is 0.5 ampere. Okay. Now let's try to do one more question. So you are given here the graph between between potential and current of two devices, and you need to measure their resistance. So here I give you the graph. This is 0. You have 0. This is 0.2. Then you have 0.4, 0.6. 0.8, and here you have 1.0. Here you are given the values as 10, 20, 30, 40, 50, 60, 70, 80. So on the y-axis, here we are representing current in ampere. So current means I measured in ampere. So not in ampere, I measured in milliampere. So let us try to determine. Okay, and for your surety, so that there is no lagging or there is no ambiguity, I am also giving you some points from this graph. So the points from this graph will help you to find out the potential. Okay. For this one, this is the point, and for this one, I can give you different points like you have this attached with this. You can also take up this point. So these are the different points which are given. Try to find out the potential of each of resistance of each of the graphs. Okay, so who can find it out? The two graphs, let me name here the graph A and the graph B. So how do I find out the resistance? Anyone, any ideas about finding the resistance? Just use the formula of
Yes,
Ohm's
sir.
law, V equals
V
to
I.
IR. Okay. So your R will be equals to V over I. Right. So for the graph A, I can take this point. For the graph A, I can consider this point. And with this point, I know the value of V and I. For this point, I know the value of V is for potential of 0.3 volt. There is a current of 50 milliampere. So it is 50 multiplied 10 to the power minus 3. Now, you can convert this. So this will be 3 multiplied 10 to the power 3 over 50. So you can write it as 300 over 50 multiplied 10. Oh, sorry. Just one. Or not multiply 10, I think it's just 300. You can check it, you will get just 300. Here it's 0.3. So 0.3 multiplied 10 to the
Sir,
power 3
6.
makes it 300. Okay, so you get here the answer as 6 ampere. So 6 ohm. So the resistance of this wire is 6 ohm. In the same way, we can find the resistance of the second wire. Anyone got the resistance of second wire?
50 into 10 to the power 3.
Okay, here it is V by R. V is 0.4 divided by 20. And here multiply 10 to the power minus 3. Again, same way. You get here 400 over 20. So 0, 0 cancels. That's 20 ohm. Am I correct?
20 ohm. Yes, sir.
You can use it here also. Even if you use this point, then also you'll get the same results. 1 divided by 50 multiply 10 to the power minus 3 will make it 1000 by 50. So 1000 by 50, so 0 cancels, and again you get 20 ohm. Got it?
Yes, sir.
Yes,
Okay.
sir.
Okay, so bye all of you. Will see some more
Bye,
questions in
sir.
next class. Okay, bye all of you.
Thank you, sir. Bye, sir.